All right. Okay. Um. Hi. Okay. Today we're gonna mock you for the next Google interview. Um.
Yeah.
Uh. Okay. To let's focus on the main part today is coding interview and skip the introduction part. Okay.
Okay.
All right. So I'm gonna give you maybe two problem or one. It depends on your performance. We only got uh 35 minutes.
Mm,
Is it true?
hmm, yeah. Okay.
All right.
But
So
interview, I got only one.
only
Oh,
one. So, okay,
only one.
one is enough. Okay. The statement I'm gonna. Okay. Given an integer array.
Mm,
Okay. With an element. Uh, positive. Okay. Positive integer. And uh, and yeah, and okay. And you need to find the maximum difference. The difference between the mass and mean. That is something like this. Okay.
mm,
uh, a sub array here is continuous. Okay.
yeah.
Of length uh, as most. Okay. Okay,
No.
you got it.
Yeah. I got it. Mm, okay. Hmm. Um. Let me see. What less than equal to k?
um yes, at most k.
Okay. Okay. That's what k.
For sure case is something like this. Yeah.
It's only depend on the number of elements. Hmm. So what? So I have a very intuitive way to do. We just iterate through answer, integer ing. We compute the the maximum minus minimum is equal uh, less than k.
um uh
Uh, uh,
that means the
at
length.
length, at length. I see, I see, I see. Okay, okay. All right. The, um, I want to have a very a simple first. I have an array I as the three, 5, 6. So we have a k like 2. So I mean every single uh, 1, 3, 3, 5, 5, 6. And the maximum difference is 2. Yeah, and the answer gonna be 2. Mm. So if we agree is to 3, so it's gonna be 1, 2, 1, 3, 1, 3, 5, and 3, 5, 6. It's gonna be 4 because the answer gonna be 4 because the array 1 to 5. Oh, if the k is 1, we can return 1. We can return 0. Is it? So we have, for example, we have, we have an array like array as uh, k, k, k elements from a uh, a k. So if we remove if we need to extend to the k plus one, it's gonna be, for example, we have the ik from one zero. Uh, so hmm, the ai minus one or I2 plus one could be Troy. Hmm. K plus one. Hmm.
So
Z plus one. So I think um I think we can do like hmm, given a difference x, we check we if it is possible to it is possible to construct an array that have a mean minus um max minus mean of the subarray uh uh larger than x, and the lineup array, not not uh is this the k. I think if we can do it, we can do with the x, so we can do a larger x. If we can not do with larger x, we can do a smaller x. So I think I can do I researched on the X first, and then I try to construct the subarray for each element. If there is any way to construct the subarray with the length, not a city k, so we can return true for it, and we find the ladder different x. Otherwise, we um, we find a smaller x. Yeah. So I think the time complexity is O n log n, or the time gonna be um and times log of max a, where a is the list, and n is the size. language like complexity is O1 because we don't have to maintain any other extra list or extra collections. Do you find it do you find it valid?
I just want to clarify how you validate if an H values is correct, is true or false about the function to check. Can you describe it again?
If I check like mm, like um, let me see. If we construct the so I think we need to for every elements. So we need to find the 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 nearest that uh, to be the right of the x. For example, I would like to have an AI like we need to for every index I we need to find the the nearest chain that having an A chain minus AI rather than X and to minus I rather than K.
Okay,
So to construct it, I think um, we need to iterate through the from the from the right to the left, and we need to start every single index. We need to start let me see. Hmm. Hmm. Seem like we need to. Hmm. Hmm. One, three, five. Like we need to have we need to start hmm, Look like we need to binary search multiple times. We have an unsorted like a collection that help us to sort it like uh,
Okay, I will give you a hint. Okay.
mm,
Um, the longer the length of the subarray is, the mean is more smaller and the mass is more larger. That's made a difference in increasing what if the length is larger. Understand?
I don't understand.
Uh, I mean the if we increase the size of the subarray, the mean
Mm,
is smaller and the
yes,
mass is larger. That means the
yes.
difference between them is increased.
Mm.
Yes,
So we need to keep the sign at mod k.
that's right. Keep
Mm.
thinking with that.
Oh, I see.
I'm back. I'm back.
Oh, I see. I have a solution for it because yes, thanks for your hint. Okay. So I think can do a better one because we should keep the array size as mod k. So the 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 problem become more easier. It's like hmm, this look like a DQ. I would like to use a DQ uh, to store the number of the. Hmm, hmm, no, I don't think it's a DQ. Yeah, I think we can use the double rarity queues to store the um to start a minimum of rank K and the maximum of rank K. Um, so every time we push a new element, we pop it, we pop the we pop the that one on import the radicule. So mm, but we introduce some like a new problem like that we need to yeah, let me elaborate again. Um, so we need to have two heap, like where heap means and heap max. The heap mean we store on the elements, we store on the elements in Windows side A, and so on, and we do the same with the uh, max, the heap max, the same. So whenever um, we we have we push a new element, so we need to pop out the element as if we push an AI to call hit, we should and eliminate remove the I minus k out of the two hips, but two hips can only like mm, I minus k. So because I minus k, we should remove impulse heap. So mm, we need to have um, immediate. Uh, I mean a middle storage to keep the um, remove it element because if the I minus k is not the mean or max value, so we don't need uh, to remove all of them in the heap right now. So we need to store in the store in the middle in the temporary um, temporary collections uh, because mm, yeah in the temporary collections when we touch in when we touch the value that value, so we need to pop it out. Hmm. So we can use a set for the middle storage set. I mean maybe uh, it's quite hard to implement in Python. I think that's super hard to implement in Python. Middle storage, we keep the removed elements. So whenever we check the min or the max value in the heap, we must check if that value is in the middle storage or not. If they not, we can use this as our value. So in general, we have the time complexity is O n log n for any design of the given list, and this is gonna be on because we need to uh, um, allocate more resource, allocate more memory for to hits. So you can find it is it is possible to do now.
I think the your main idea is good, but about the middle storage here, it sounds so complicated. I still don't understand why you use temporary storage here. It sounds so ambiguous. I still
Uh,
don't understand.
because yeah, because we need to when we remove an element, uh, when we remove it, remove an IMSK. So we need to because it's not the mean of the mean and it's not a max of hit max.
Yes, yes.
So we don't need to remove it immediately. We need to have a middle storage to keep the AI in SK in the storage. So whenever we have we check the the, the, the smallest value in Hitmin, we uh, we check if it is in the middle storage or not. If it's in the middle storage, we pop it out because it is removed already. So we pop it in until the smaller value is not in the middle storage.
But I have problem. How can you maintain the hip size always case?
Mm, the hip size is not always k.
Okay, it's less than or equal to k, right?
Yes.
But how? Because you actually you don't delete that value out the heap, so the size it keep increasing.
Yeah, the hip, the size of hip keep increasing. So that's why I have an ON by here.
But I you need to maintain the you said you maintain at most k elements in the heap, but you
Uh,
actually you don't delete it out the heap, you know.
yeah,
So I don't know how you can maintain the size of the heap.
the hip, the size of hip doesn't reach the size of the end, then never reach the end elements. Yeah. So I think the spy ON is feasible to implement now. Do you have any suggestions on spy optimizations?
Um, about the space is okay, but I'm afraid about the pop out implementation is so complicated and may maybe incorrect because when you push you insert a new element, you need to delete the last k, and you
Mm,
actually you don't delete it, right? It's still in the heap, but you check in only like mark it on the temporary storage. Um, so I mean the size in but actually we only need to maintain the last k element, but in the
mm,
heap, mm, it's like you will uh, as far as I understand about your solution, you maintain the heap is made up to n, right? Up to n,
mm,
and when you meet the mean is like in the delete array, you will pop it out until the mean is in the range of I minus k to I. Mm. Okay, I got it. I got it. Okay, it's not feasible, you know. Mm. But in actually in Python, you don't have a set, right?
yes, in Python it's not set. The set is actually is a hash table. It's not a tree set. So it's quite challenging to implement this kind of.
Okay, okay, but I think your solution is incorrect. You could implement this now.
Okay. Oh,
Yeah, but actually, I expect I expect the time is smaller.
the time is smaller.
But your solution is correct. I said it's correct, but I expect the optimal solution.
The optimal solution.
Only ON. Can you um, brief thinking about it, brainstorming about the solution?
Okay. I think we can use a DQ like um, I think I have a solution for it. Uh, so uh, I think we can use a DQ like to find the maximum number in the range of 6K window. So yeah, uh, we have a DQ like to maintain the size of the array, to maintain the array with a size k. For example, we have from A1 to A2, AK. So whenever we push uh, uh, an element AK plus one, we need to we need to check if um, uh, for example we are finding the smallest value in range uh, to k plus one. So if the A1 are gonna be pop out because it's out range now. Yeah, and we need to push the AK plus one to the DQ. I mean, this is a DQ now, a DQ. If we push the AK plus one, we need to pop the AK where they have larger than had a value larger than the current value AK plus one. So if the AK larger than the AK plus one, we remove it till we have we remove AK because it's larger than or equal to AK plus one. If the AK minus one still larger than AK plus one, we should continue the processing until we got an X some X that have value larger than less than the AK plus one. We can stop processing, and then a new queue is contain only the the range here. So if so the mean value of this case is 82. So we do the same process with the finding the maximum value in the range in the fixed k size. So yeah,
Yeah, yeah, got it. Yeah, I think it's a good solution as your given solution is clear. Yeah, clear enough to me. So would you like to implement it using the previous solution or the new solution?
I think the new solution is
Yes.
easier to implement.
Let's do it.
Yeah. So uh, so we need to implement làm sao từ từ để tắt cái uppercase, làm sao để tắt cái uppercase này,
Không biết.
có chân đốc mệt thiệt.
Damn.
Okay. Uh, so we okay. So we have we have to find maximum difference given an array plus a list integer. So we can return the the integers. So we had an n as the length of a. We have we have a we should import the from the queue import the queue. Actually, I don't understand the syntax. So
That's
we
good.
have the feel like Q. So let me we had a master Q and a mini Q. Like we need to allocate them to here, and we have an answers like so. Um, for every element in the range, and we should why the max Q, minus uh, uh, so, uh, Q0. We should store the index in this instead of the number, the value number larger than mm, I mistake or I forgot it here. I, a bit so minus minus zero. So we public master Q we public y mean Q zero. In this case we can mean Q dot pop. So where we push the AI to the K to the max Q and the Q. So yeah, why why master Q or M so we can Q and master Q. Oh, I mean the Q minus one. Um, I mean the A less than the AI. So we can put it above is the above left is the above right. Sorry, above left also above right. We do the same with the this, mm, next. Hmm. Let me go through go to the new page for better vision. So here's the AI. Here's uh, so the answer gonna be max adventure in max CPU user minus the min q user. So we can return the answers. We need to push the master queue to push left, push right, and also with the min queue, push right. Yes. We have that here, so we check if I less than larger than k. So we need to do this, and we do return answers here. Hmm. I think hmm, we are done now.
I want to give an advice. Ah, no, it's good, it's good. Uh, you don't need to check the empty here. Is that true? Is that true?
Yeah, yeah, yeah. That's right. That's right. Not good. Yeah, yeah, yeah. That's right. That's right. Oh, I see.
Okay. Just run some test case.
Okay. So, given that it's like this, so in K3, do you want to a little bit more complex also input? I experience, yeah, in follow. So I'm gonna be 1, 2, 3, 4, 5, 6, 7. Okay. So uh, we have I gonna be 0. So because I not larger than k, so we cannot if we don't consider it, and the people need to be I think we need to check if the queue is not empty, not empty, and the min queue is not empty. So because of the math, so we move it to mm, the mass queue is queue, queue gonna be 0, and mini queue gonna be 0 as well. So iterate go through 1 is uh, if not if give it um, we, because it's not empty now. So we check it if the min queue, right? the mid Q, the max Q, because one is less than the two, so we don't need to prove it. And the max Q, the mid Q is gonna be remove the two from the mid Q, and because both of them, one of them is the mid is not is empty now, so we skip it. We push it again to 0, 1, and 1 here. We keep the iterate to I minus 2, I gonna be 2. This is 3. Uh, Skip it. Uh, it's gonna be 3. 2, 2, 2. Because 3 is larger than 1, so we got it. And we got again the 2. So the max queue is empty now. Hmm. I think if we
See some problems here.
yes, we need to boost um, to make sure that all of them are not empty now. So we ignore this. So yeah, uh, the max queue now is empty, and the min queue is one because three is lower than one. So we put the two and two. So we keep the two minus three minus the one here. The answer gonna be the answer gonna be two uh, three minus one is two. And now we iterate keep iterate with three, and it's not skip this part, and this part is two, and five is larger than three, so we pop it. So this one. Um, we don't because five is larger than one to three, so we keep it. But two, so we push it again to five, and oh no, sorry, it's gonna be three. It's three, and the answer bit to the five minus one is gonna be four. And then we go through the six. It's gonna be this is four. It's four now, and we we need to pump the the orange the outlet index is in zero. So but the uh, the left one is not uh, it's not it's not orange. So we don't process this part as well. So we keep to this uh, AI six. Six gonna be six. Six is larger than five, so we pop it out. We have we have um, we have a empty max queue, and we have the queue mini queue. We got again uh, push it again to four, and we uh, we append it to again four here. So we update maximum six and one and multiply, and we iterate to the I gonna read five here. Eight, eight. Uh, because five rather than four, so we keep we check the maximum. The max is four, so we don't reset this line. We reset this line because one is like less than uh 5 minutes. Right? No. So we pop it out. We're gonna two, three, four. We continue it. We pop it out again, and uh, we append it again, and yeah, we update the result as the seven. No, as a two. It still be five. Don't update. Don't update the again at range. It's the continue with six. I think it's gonna be uh, mm, we pop it. We pop them in DQ again, and seven will be the min DQ will be updated to we don't update the max DQ. We update to seven here. Oh, sorry, it's gonna be six, five, six, and we update again. We answer like we uh, the answer doesn't change. So the answer the final one is five. Yeah.
Okay, okay,
Mà
get
mỗi
get.
lần chạy cái viral kiểu phải có cách nào đó để nói cho nó ý là nó sao ta nó ờ, làm sao để viral nó nhanh hơn á.
Và Vân thì chắc Vân từng bước vậy là đúng rồi. Yeah.
Không biết có skill nào để skip không tại vì kiểu tới đây thôi chắc là cũng được rồi.
Đúng rồi. Dạ ok mà.
Ừ.